Okay, so we're going to talk now about this balance that exists between acids and bases. And it's called an equilibrium. That's what scientists use to talk about balance. It all comes from this concept called the self-ionization of water. So if you look at the cup of water in front of you, what that means is of all of those millions of water molecules that exist, some of them have ionized. Some of them have broken into their hydrogen ion and their hydroxide ion. That's the beauty of water, as to it can be both an acid and a base depending on the situation it's in. So if we look at this, a self-ionization of water just means that it ionizes into those two ions, as I said. But here's the key: it reacts with itself. So that means that if you have two molecules of water, one molecule of water will pull off the hydrogen ion from the other. So now this is an H3O molecule. We call it hydronium. You're going to learn that in a minute. And this one is left just a hydroxide ion, an OH ion. That's what we mean by the water reacts with itself. And then almost as quick as it does that is it gives its hydrogen back, and now they're off two water molecules again. So this happens constantly as these water molecules are bouncing and colliding into one another. That's what the reaction looks like. This is that formula for hydronium that we talked about. H3O plus is a hydronium ion. So if you had two water molecules, you'd end up with a hydronium ion and a hydroxide ion. Hydrogen. Remember, a hydrogen ion is also simply a proton. There is nothing else in that ion besides that one proton. Hydroxide, you know that one. And here are your new one, the hydronium. Okay, question. What do acids release? This is from the last video. I hope you said it. It is protons. Acids donate protons. What is formed by the protons released by acids? So think of an acid being dissolved in the water. The acid's giving up a lot of these free hydrogens. The water can pick up those hydrogens. When the water picks up the hydrogen, it forms hydronium. Okay, that's how that hydronium is being formed. So we have what's called an ionization constant. That means no matter what with this water, it's going to ionize into the hydronium hydroxide at a consistent rate. This is an equation you do not need to know or understand for this unit, but I wanted you aware of the chemistry of it. We call this constant Kw. It's the ionization constant of water. This value is always the same value, and it equals 1 times 10 to the negative 14th. So that means 0.1301 amounts of molecules has ionized. That's a very, very small amount. So you're not drinking a bunch of ions. Most of that water are full water molecules, but a very, very small amount of them have ionized. However, this value becomes very important as we talk about acid-base chemistry. So, because of this mathematical relationship, if your hydronium ion is 1 times 10 to the negative 10, then your hydroxide ion makes up the rest, which is 1 times 10 to the negative 4. If your hydronium was 1 times 10 to the negative 3, then your hydroxide ion would be 1 times 10 to the negative 11. Notice this relationship. If I multiply these two numbers together, I'm going to equal this ionization constant of water. This is the case with all acid-base chemistry. So let's look at this. Oh, let me go back to this for a second. you'll notice these square brackets. Those square brackets are shorthand for concentration. We learned in chapter 14 that concentration is measured by a number of different things, but most commonly it's measured by molarity. So that's that capital M, moles per liter, molarity, and this is the shorthand for it. When you see square brackets, we're talking about a molarity concentration. Okay, so if the concentration of hydronium ions is found to be 5 times 10 to the negative 7th moles per liter, what's the hydroxide ion concentration? Plug this into that Kw equation. Hydronium times hydroxide is going to equal 1 times 10 to the negative 14th. And then you can just use your algebra to solve for it. So if Kw was 1 times 10 to the negative 14th, your hydronium is your 5 times 10 to the negative 7. I was right, okay. You just plug it into your equation to solve for hydroxide. Then you're going to divide 1 times 10 to the negative 14th divided by your hydronium concentration. And you put in the values and you get your hydroxide concentration. Try it with your calculator. Pause the video, try it. This is what you're going to get. This is how you do it. Okay, so since Kw is 1 times 10 to the negative 4, and we know that this relationship between hydronium and hydroxide and Kw exist, we know that one water molecule can self-ionize. We also know that in water, H3O plus and OH negative, hydronium and hydroxide, must equal one another. That's only in water. So therefore, 1 out of about 555 million water molecules are ionized. Small amount. Okay, let's talk about this thing called pH scale. You've heard the pH of this is that the pH of water is 7. Neutral is a pH of 7. Like, you've heard this thrown out. You may have even heard, the buzz thing right now is to drink alkaline water, right? Because we have so many foods that we eat that are acidic and we need to neutralize our blood. That's all based on this pH scale. pH stands for the power of hydronium. So we're going to be looking at that concentration of your hydronium ion in order to find the pH of a solution. pH is a negative logarithm. You may have done logs in Algebra 2 if you've had it. If you're in geometry, you're going to hit logs next year. For my class, I'm going to tell you how to do it on the calculator. Let the calculator do it for you, okay? So, to calculate the pH of any solution, if you know the concentration of the hydronium, all you do is plug into your calculator negative log. Okay, so I went and paused the video and got my calculator because I want to show you where on your calculator you're going to find this log button. So the way you use it is the log button, if you can see, is right there on the calculator. Okay? The way you'll do this is you'll put log and it'll give you a parentheses started. And then you'll put in your concentration. So say my concentration is 1 times 10 to the negative 7th. You want to close your parentheses so that your screen looks like that. And then you hit enter. You'll always get a negative number if you do that. Well, if you just take the negative of that negative number, you're taking the negative log of your concentration. So what I found out is that if my concentration of hydronium is 1 times 10 to the negative 7, then my pH is a 7. Well, what solution has a concentration of hydronium of 1 times 10 to the negative 7? Hope you said water, because that's what we just learned, right? So what's the pH of water? 7. That's how this math works with this. Okay. So that's the one I just found for you, right? You try the rest of these. Once I put them on the screen, you plug it into your calculator and see if you can get that the pH of each of these solutions is what I say it is. Good job. So what do these values mean? Well, we already said that if you have a pH of 7, just like water does, this is considered neutral. If, however, you have a pH that's less than 7, so from 0 to 7, this is considered an acidic solution. So low pH values actually mean high concentrations of hydronium, which means lots of H's, lots of protons being donated. This is what acids do. So therefore, low pH. If you have a high pH, this actually means low concentrations of hydrogen. So these are basic solutions because those bases take those hydrogens out of solution. So acids, pHs of 0 to 7, bases, pHs of 7 to 14. Just showing you. All right, let's try a sample problem. Hydronium ion concentration in a shampoo is 2 times 10 to the negative fifth. There's your molarity, your concentration. Let's take the negative log of this concentration and we'll find the pH of it. Negative log of 2 times 10 to the negative fifth is a negative 4.7 or a pH of 4.7. Try it on your calculator. See if you can do it. If you can't, come find me in a Zoom. Here's another sample. What is the pH of an aqueous solution that has 0.4 grams of hydrogen iodide dissolved in 500 milliliters? Well, you've got to find your concentration first, don't you? So you've got to find your molarity. Change those grams to moles, right? By using that molar mass. We find out that we have 0.0031 moles. Use that moles divided by your liters, right? We had milliliters, we need liters. You would end up with a concentration of 6.3 times 10 to the negative third. You need to find the log of that and get the negative of that log, and you would find that your solution has a pH of 2.2.